In this video, I will be presenting the IP tables. It's a very famous and open source firewall program for the Linux operating system. Actually, this IP tables is a user level program that controls the kernel level network modules called netfilter. This IP table commands, whatever we'll write, will be written on the console. So these commands will manipulate the netfilter internal structure, which is available in the Linux kernel. So this IP tables IP table commands must be executed in the root mode or administrative privileges. Then only these commands will manipulate the kernel or netfilters which are available in the kernel. If we look at the netfilter architecture, the netfilter consisting of three main components. One is filter table, next one is network address translation NAT table, another is mangle table. Actually, these tables will be managed with some chain rules. The chain rules are majorly the input rule, output rule, and forward rule. In case of network address translation, pre-routing rule, post-routing rule, and output rule. We'll see one by one what is meant by filter, NAT, and mangle. Filter is nothing but or the filter table is one of the widely used tables for implementation. Actually, this filter table is used to make decisions about whether a packet to be allowed into the computer or into the system or not. That means the packet continue its intended destination or deny its request or not will be written in this particular input rules, that is especially in the filter rules. In firewall, this is known as filtering packets. This table provides a bulk of functionality that people think of when discussing the firewalls or when writing the firewall rules. The NAT table, especially used for the network address translation. When a packet enters the network stack, the rules in the table will be determined whether and how to modify the packet's source or destination address in order to impact the way that the packet and any response traffic are routed. That is nothing but taking the traffic from one network interface and diverting the same traffic to the other network interface. This kind of things will be written in the network address translation. And this is also often used to route the packets to network when there is no direct access possible. It is just like from public to the private address. If you want to divert the traffic from public NIC to the private network, then this NAT table will be helpful for us. We will see in this video how this NAT table can be implemented. Next one is mangle table. The mangle table is used to alter the IP headers of the packet in various ways. For example, changing the value of the TTL to increase or decrease the number of hops that a packet has to pass through. So these kind of things you can manage with the help of mangle table. So these are the main three tables that are available, and there exist some other tables like the raw table, security table, and many other tables are available. Basically, raw table is nothing but it provides a mechanism for making packets in order to opt out of connection tracking. Basically, this raw table will help like that. It is having very limited functionality. Usually, this will not be popularly used. And there is another table is also available in the netfilters called the security table. This security table used for the per packet and per connection basis security checking, or some rules to be imposed for per packet or for every connection that will establish with the system. But out of the available tables, majorly the mangle table, filter table, and NAT table are popularly used. The raw table and security table are having limited usage. Here is an example that which chain are implemented in each table. Here the tables are like this raw table, that is general table. Mangle table, NAT table. In that NAT table, we have two categories: dynamic NAT and static NAT, and security table. So here, these are the chains like pre-routing, input, forward, output, and post-routing. So in Mangle table, you will find all the chains like pre-routing, input, forward, output, and post-routing. So this is the table summary with which chain is implemented in which table. Here is the example of using IP tables. As I told you, IP tables must be used in the root or administrative privileges because they will directly manipulate the or send the commands to the kernel. So sudo IP tables -t. -t is the filter name that we are supposed to mention here. -t filter, that is the command list that we are supposed to hear, and -l. L is to list the commands or list the rules that we have injected into the IP table. And here the IP table rules will be like this. You look at here input, forward, and output. Input is for the incoming connections, and forward is to which connection to be forwarded, and output is for the output connection. So there is one rule set in the input chain here. If you look at that is the drop connection. That is whatever the packet to be dropped that was written here. Here the command is drop, and what type of traffic to be dropped is here the protocol type is ICMP, and here source is anywhere, from anywhere to anywhere. If any ICMP is coming from any IP to any IP, if the ICMP is ICMP echo request is coming, then that request will be dropped. So the other two chains will be like this. The forward chain and output chain will be here. You can see here. So how to enter this particular rule? This rule can be entered via the IP tables filtering options that we'll see next. The rule in the input chain means when a packet with ICMP payload passes through the input hook, drop the packet, no matter from where, from anywhere to anywhere, irrespective of the source or irrespective of the destination. If it receives the input, if the packet enters the system, then that drop the packet. This is what the idea of this IP table filtering rules. Now we'll see the example of how to add the filter. That is sudo IP tables -t filter -a. That is add filter. That is -a is nothing but adding of the filter. -a input. That is you are supposed to make the entry addition of this rule into the input chain. Input -- protocol. That is the protocol name that what you want to mention. ICMP -- jump drop. That means whatever ICMP packet is there, that will be dropped. But if you want to mention the specific address, then you are supposed to mention the other options for this along with this filter, such as which Ethernet card that you are receiving, which Ethernet card that you are forwarding, this kind of thing. But here from anywhere to anywhere, that is from any source to any destination, you want to drop the ICMP packet. So here no need of mentioning anything. By default, it will consider as anywhere to anywhere. If you won't mention any Ethernet address or Ethernet or IP range or something, if you simply say that -- jump drop means what are the packets of ICMP type is, all the packets will be dropped. And after setting this rule, you can list the rules like as we have set in the previous example, previous thing, like sudo IP tables -t filter -l. So thereby you will get the inserted rules into the IP table. Other IP table filtering rules will be like this. Clear all existing rules. In order to do that, you need to use the filter -f, that is flushing of the rules. That is IP tables -t filter -f. That will flush all the entries in the table. Flush all entries in the NAT table. Then IP tables -t NAT -f. If you want to flush all entries in the Mangle table, then -t Mangle -f. List all entries in the NAT table. Just now we have seen like how we have gone for showing off the filters in the normal table. Like that, in the same way, you are supposed to do for the NAT table also. IP tables -t NAT -l. And since IP tables is a open source and free tool, you will find the documentation online. You may go through the documentation for further references. Here are the list of states to be used with the IP tables. The first state is new. That means when a packet arrives that is not associated with the existing connection but not involved as the first packet, a new connection will be added to the system with this label. This happens for both connection aware protocols like TCP as well as for the connectionless protocols like UDP also. Established is nothing but a connection is changed from new to established state. In the new state, the synchronous signal will be received, where in case of established state, the synchronous acknowledgement and at the same time acknowledgement from the sender will also be received. Thereby, a well-established connection will be established there. Related, that is packets that are not part of the existing connection but are associated with the connection already in the system are labeled as related. Like for example, in the case with the FTP data transmission connections, this kind of things, like for example ICP, ICMP requests, these kind of things are said to be related. Invalid packets can be marked invalid if they are not associated with the existing connection and are not appropriate for opening a new connection if they cannot be identified or if they are not routable among the other reasons. Untracked. Sometimes some of the packets are marked as untracked if they have been targeted in a raw table chain to bypass the tracking. Especially many attackers will do the evading of the firewalls, so they may use this kind of thing. SNAT is nothing but static NAT, a virtual state set when the source address especially, has been altered by the NAT operations. This is used by the connection tracking system so that it allows or it knows to change the source address back in the reply packets. Where in case of dynamic NAT, it will be done dynamically, a virtual state set when the destination address has not been altered by the network address translation operation. This has been used by the connection tracking system so that it knows to change the destination address back when the routing reply packets is coming back. In the static NAT, in general, the administrator or system administrator has to enter manually what is the public IP and what is the mapping IP. Where in case of dynamic NAT, it will be done automatically so that even though the packet or if any communication has to go in reverse direction, they no need to keep track of what is the convertible IP addresses for the internal and external networks. That is, these are the list of states in which we will use new, established, and related states are frequently in establishing the rules for the IP tables. Now we'll see how these IP tables will be used on the Linux operating system with some examples. Now I will show you how to use these IP tables in the Linux operating system. So for that I am taking the Kali Linux as the base operating system. So for the Kali Linux I have set the network adapter as the host only adapter, and I will use one more adapter called NAT adapter so that I can divert the traffic, that is internet, from the NAT to the local area network, that is host only adapter. I'm going to select the NAT adapter along with the host only adapter to show what are the internet coming on to the NAT adapter to be diverted to the host adapter. At the same time, to set a particular configuration or to set some filtering rules for the host only adapter. And I'm using Windows 7 for testing our connectivity. So Windows 7 is configured with the host only adapter. Now what I'm doing is for Kali Linux, along with this host only adapter, I'm using connecting NAT adapter also. So here enable the NAT adapter. So here adapter is the type NAT. That means this Kali Linux is having two network interfaces. One is with NAT connection and second one is that is host only adapter connection. Now we'll see the IP tables. We'll type the IP tables and enter. That means IP tables is already installed in the Kali Linux. If it is not installed, then you may go for if you are not using in the user mode, root mode, then you may go to the sudo apt install IP tables. Anyhow, on my computer the IP tables were installed. If your IP tables were not installed on your computer, then you may go to the sudo apt install IP tables. And the prime requirement for the IP tables is you must use the root access. That means either you may be a root or you have to use the sudo command for performing the or framing the rules and injecting into executing those commands to execute the firewall rules. Now we'll see the IP tables options here. IP tables space help. So this IP tables help will give you the various options here. See, these are the various commands that you can use, and some example usages were also given here. You may follow these example usages, or some of the examples I have provided in the description section also. You may download that file and you may also practice them. And also I have given some references. According to that also you can practice these IP tables. To list the available rules in the IP tables, you may go for IP tables -L. So this IP tables -L means it will list the available rules. As we have seen in the slides, the rules will be like this: input chain, forward chain, and output chain. Here, since I have not mentioned any rule here, then what I have, that is the reason we don't find any rules over this particular chains. So now what we'll do is we'll try to see the IP address of the like Kali Linux ifconfig. So here in the Kali Linux, I have included two network interfaces. One is the network interface with the NAT address to share the internet connectivity of my host computer to the Kali Linux virtual machine, and another network interface is to connect to the local host adapter, that is a local area network of series 19.168.1.33. That is, here the series is 19.168.1.1 by 24. Whenever this ifconfig was typed, you look at here ETH0. This is the Ethernet Ethernet 0 and Ethernet 1. Ethernet 0 is related to the NAT address, NAT adapter, and Ethernet 1 is with the host only adapter. And Ethernet 0's IP address is not showing here because this is not active, and Ethernet 1 address is showing because it is active. So whatever is active, its related IP addresses will be shown. But in Kali Linux, we can, by default, only one network interface will be active. We should, if you can choose, or you can shift between the network interfaces. Which, for example, if I want to enable the NAT adapter, then click here and again you type this ifconfig. Now you look at here, Ethernet 1 related IP address was not showing. So that means Ethernet 1 is disabled now, and Ethernet 0 is enabled, and the series 10.0.2.15 is showing here, which is the network address translated address. So like that you can shift between the interfaces. So currently what I'm doing is I'm shifting to the local host only adapter interface. Now the host only adapter is off. So this is the way you can shift it. I will show you afterwards how to enable both the network interfaces at a time. Not only both, any number of interfaces that you have are connected with the virtual machine can be enabled at a time and can be used. That I will show you in short while. Here is the Windows operating system, Windows 7, in which I am opening the command prompt. Now ipconfig. So here the IP of this Windows 7 is 19.168.1.42. Now I will try to connect to the Kali Linux via ping command, ping 192.168.1.33. So that means it is connecting to the Kali Linux operating system. That means the Kali Linux is responding to the ping request. Now what I will do is I will write a rule in the Kali Linux so that that is IP table rule I will write to deny the ICMP request. Recall the command that I have presented in the lecture slide: IP table -t filter -a input, because we should not allow the input. So what protocol we need to allow? That is protocol ICMP. That means which protocol we need to focus on. That is protocol is ICMP, and jump drop. So here it is IP tables or table Now the rule is entered into the IP tables. Now what we'll do is we'll see IP tables hyphen capital L. So it is just like looking like how we have used in the how I have explained in the lecture slide. The same way you will find here drop ICMP anywhere. Now we'll shift to the Windows 7 and we'll see whether the ping is going on or not. So you can see here the requested timeout because the Kali Linux is not responding to the ping command. The reason is we have included the firewall rule that not to accept the ICMP request. Now we'll go back to the Kali Linux and that will flush the rules that are entered. IP tables hyphen L already the dropping of the ICMP was there. We'll flush it. Like how we'll flush this IP tables hyphen capital F. If you want to flush only the input related rules, then you can say input here. Otherwise, you can type. Otherwise, if you mention as hyphen capital F, then all chain rules that are entered in that are entered will be flushed. Now, I would like to flush this table. Now, we'll see whether the rules available or not. Hyphen capital L. So here, previously drop table chain rule is there, but now there is no drop table chain rule. Now we'll move back to the Windows 7 and we'll see the traffic of ICMP. Now you look at here, the traffic is going on. So that means we are going to allow the ICMP traffic to the Kali Linux via IP table chain rules. In this way, here are the list of commands that we can use with the IP tables. The first one is, as I told you, that if IP tables were not installed, then you can use IP table apt-get install IP tables. You may use that command. And you want to save the IP table rules permanently, then we require a tool called iptables-persistent. Then netfilter-persistent save is the one command you are supposed to use for saving the table rules permanently. And next one is to accept all traffics on your loopback interface. Loopback interface is nothing but the local host interface, that is 127.0.0.1. Any request to localhost and a reply from the local host to be accepted, then you can write a table chain like this, a rule like this: IP tables -a accept the input from the local loop LO -j accepted. That is the operation to be performed. Next is to allow established and related incoming connections. We have seen the states there, like established, related. That means the connections that are already established and the related packets of the established connection will be accepted. Where here IP tables -a input, that is input. This is the input rule that we are supposed to mention, and -m is the match. Match in the sense the connection tracking match. That means the recently established connections will be tracked and related match will be maintained. Whenever the connection is established, the match will be like this: conntrack, conntrack, connectrack. You are supposed to use this connectrack for any established connection. Next one is to allow established and related outgoing connections. That is, you are supposed to use the output state, okay, output chain you are supposed to use. And if you want to forward from the internal to the external, that is diverting of the traffic from the internal to the external, then the forward rule need to be set. And if you want to drop the packets, that is all valid packets which are related to a connection, then IP table -a, since the valid packets are nothing but the input packets which are coming into the computer, so -a input -m connection track that need to be dropped. And to block a particular IP address, so IP table -a input -s the IP table. We can also experience it. We can also experience it on our current thing. Like So here input table, IP tables hyphen a input hyphen s. Now what I will do is I will write an IP address, the IP address of the Windows 7 operating system 19.168.1.42. Now IP tables hyphen l. So here drop all, whatever the packet will come from the 19.168.1.42. Now let will go to the Windows 7. Again we'll rerun the ping command and we'll see whether connection is accepted or not, or the traffic is accepted or not. So ping is not accepting. The reason is the IP address is blocked. In the same way, one may also go for blocking of the entire subnet. So in order to block the entire subnet, one can do is the network ID and the subnet range need to be mentioned. The thing is like this: IP tables hyphen a input hyphen s 19.168.1.1 by 24 hyphen j drop. That means any packet that is received from this IP range, subnet range, will be dropped. So this is the way we can set the IP rules. Next is to block the network interface. We have seen previously ETH0, ETH1, like that some network interfaces are available. If you want to block entirely the network interface, you can mention hyphen I. I is for the interface. ETH0, you can block the ETH0 like this. And now you can also block the particular services. If you want to block the SSH service, then you have to mainly focus on the port 22, telnet service 23, HTTP 80. Like that, you have to remember the port numbers. For example, you don't want to remotely connect to the MySQL server. So you want to write a rule, then the port need to be focus on is 3306, PostgreSQL is 5432, IMAP is 143, POP3S secured is 995, Post Office Protocol 3 is 110, like that. A simple example here: SSH IP tables hyphen a input rule it is, and the packet, because this SSH will use the TCP as the transport layer service. SSH is at the application layer. It uses the transport layer service at TCP, and destination port is 22. So since it is using 22 as a destination port, and the connection track is conntrack, because which is established connection. The connection state will be like a new established, whether it may be new connection or maybe established connection, accept. And outgoing connection, only the established connection related traffic will be accepted for the outgoing. So in this way you can make the security. At the same time, we can also accept the request to SSH to from a particular range of IP address. Like for example, from a subnet hyphen s, the network ID by 24, as we have seen previously. In the same way for the telnet uses the 23 as the service, and HTTP for which uses the 80 port. So like that, we can also use the database related things also, like MySQL, PostgreSQL, etc. And next one is listing the rules and other commands. By specification, if you want to list the rules, hyphen s. If you want to list the rules which are specific to a protocol, then hyphen s space TCP. Like for example, only TCP related rules will be displayed. And if you want to display the rules according to a table, then like hyphen L, as already we have experienced it. If you want to show only the input rules, hyphen L input. And showing packet count and aggregated size. What are how many packets were received, and what is the size of each packet, aggregated size of the packets that are received so far. You can get it as IP tables hyphen L input hyphen V. Deleting rules by specification. You can use the delete rule option like this. Next is deleting the rules by chain number. You can give a line number so that the related rule will be deleted. And flushing all the rules, IP table hyphen F. Now what we do is, these are the rules. Okay. So this you can find in the description section of this video and also in the Google Classroom. So you download from Google Classroom or description section. You practice from your end. This is related to the brief introduction of the IP tables. Now we'll go to the activating of the NAT. That is diverting of the traffic from the one NAT address adapter to the local area network adapter, that is host only adapter. As we have seen in the Kali Linux, that only one interface is active at a time. So we need to both the interfaces to be active. So how is it possible to make both the interfaces active? So for that, a simple explanation, simple thing that you are supposed to do is, here I have given the notes for that. You may follow this. So you may go to the network interfaces and just you copy paste this command there. Just you copy paste these commands there. Like first of all, by default the loopback adapter will be on, and NAT is by default auto. That means you set it to auto, means whenever the system is booted, then automatically the Ethernet 0 is also enabled. In the same way, iFace, that is what is called interface. Ethernet 0 is set to the DHCP, and that is Ethernet 1 is also by default automatically up, and iFace ETH is set to DHCP. So that means when by setting this, if you restart the computer, then automatically both the restart the computer in the sense here restarting of the virtual machine. If you restart the virtual machine, that is Kali virtual machine, Kali operating system, then from the next reboot onwards, both the interfaces will be active. Once both the interfaces are active, we know that the ETH0 is linked with the NAT interface, and ETH1 is linked with the host only adapter. Now I will use this command providing the internet on LAN, that is the Ethernet 1, which is the host only adapter series, and I want to perform the traffic diversion, internet traffic diversion to the local area network, that is host only adapter. So for this, I will use these three rules in the IP tables, so that this traffic from the, that is internet traffic on the local area NAT adapter will be diverted to the local area network. So these are the three rules. First, what we do is we'll go to the network interfaces and we'll copy and paste there, and restart the system so that both the network interfaces will be active. Here I am using the mousepad tool for editing this. Mousepad/etc/network/interfaces. So anyhow, this auto turning on the loop adapter is there. Just what I'm doing is I'm pasting the rest of the two, that is just NAT adapter and at the same time host only adapter, and save this, and let's go for reboot. We know that whenever we go for the ifconfig, when both the network interfaces IP addresses are shown, that means both are active. So you look at here 10.0.2.15 and 19.168.1.41, both are active now. Now we can also access the internet on the computer because the NAT address is also enabled. So let us check the google.com. Well, Google is appearing, that means internet connectivity is there. The same way, let me go for the Windows 7 operating system, which is on the host only adapter, and let will go for checking whether can we access the internet or not. So let will enter the google.com and we'll check. So here Google cannot be accessed because there is no connectivity. It is in the local area network, that is in the host only adapter. Now I want to divert the traffic, or I want to make this particular local host adapter to make use of the internet. So for that I will write a rule in the Kali Linux. So the Kali Linux will become the diverting server. So whenever the IP firewall rules were executed, that is IP tables rules were executed, then the traffic will be diverted to the local area network, that is any system which is using on the local host, that is host only adapter. Now we'll try to understand the IP rules that we are supposed to set here. IP table -t NAT host routing. We are supposed to mask word the Ethernet 0. Mask word means we should prepare for the diversion. Then IP tables, and also with the masquerade we are going to hide the configuration of the NAT and all. Next one is IP table -a forward, that is from the Ethernet 0 to Ethernet 1. The input interface is Ethernet 0 and output interface is Ethernet 1, and the marking is like that, state, and the state is related, anything is related, established. So that state will be sent forward to the Ethernet 1, and finally you are asking to accept that connection. And IP table -a forward Ethernet 1 at same time from the vice versa also, not only from Ethernet 0 to Ethernet 1, because the internal request should also go to the public. So Ethernet 1 to Ethernet 0 accepted. So these three rules must be inserted into the IP tables. It should be executed with the IP tables to enable the traffic from the network address translation adapter, NAT adapter, to the local host adapter, and vice versa. Next, we should go to the etc systemctl.conf. There we'll be having a variable called net.ip4.ip_forward is equal to 0. Then this should be changed to 1, so that IP forwarding will take place. So now what we'll do is, first we'll go to the /etc/systemctl.conf, and we'll change the value of this parameter ip4.ip_forward is equal to 1. So here mouse pad. In this, let us search for the net.ip4.conf. Here is the command. Here is the one, net.ip4.ip_forward. Let uncomment this. That will uncomment this, so that the IP forwarding will take place. Then use service network restart. Otherwise, let us go for reboot, so that it will be reconfigured again. After reboot, let will enter the IP table rules. First, the masquerading rule. Then we'll use the second rule for diverting the traffic, which is already related and established. That is from ETH0 to ETH1 we are diverting. Next, we use the reverse also, that is from ETH1 to ETH0. So we did it. Now what we can do is that we'll go for checking whether internet is available on the Windows 7 or not. So that again, we'll type this google.com and we'll try to enter. So still Google was not found. The reason is we need to go for inspection of the network interface. That will enable the IP forward again on the Kali Linux, and we'll check again. And we'll go to the Windows 7 and we'll try to check again whether that will cross check the IP address of the Kali Linux. Okay, the Kali Linux IP address is 1.41. We need to configure the Windows 7 with a gateway as 19.168.1.41, so that we can access the internet on the Windows 7. So here let us change from the 33 to 41 and OK. So it is asking for whether you want it is a home network or any other thing. So let us say home network. So now a network is establishing. Now we'll see that will ping www.google.com. Yeah, response is coming. That means we are getting the internet. So let will go here. So it's great. We got the internet on Windows 7 because of the IP forwarding done by the IP tables rules that what we have said. That means we have seen in the lecture that firewall will do the filtering, network address translation, and logging. So I hope by this time you come to know the functionality of the firewall and at the same time the functionality of the IP tables in the Linux operating system.